Hello, this is the Tepid Coder. Today I want to talk about enumerations. I've been putting this off for a while because they're a bit complex to explain, and there's some differences between C and C++ that can really trip me up when trying to explain it. So I'm just going to get a basic project started here. I'm going to do an enum. So it's enum, name of the enum, and then we're going to do a block of code where you're going to stick your member names in, and you end up with a semicolon just like structures. So I'm going to call this enum numbers, and I'm just going to label some numbers. 0, say 1, 2, I can type 3, 4, whatever. Now, something to note about this, the way I've typed this is the C way, and the C way is automatically implicitly convertible to an integer. And not only that, but all of these values share the scope that it's currently in. Right now this is in global scope, it's not within a function. So anything in the entire project that has these same names is going to clash, and it's going to be complaining about a redefinition error for the symbol when it's compiling. So I'm going to show that in a second, but first I'm going to show it being implicitly convertible. So I'm going to say int x equals numbers 0. I'm going to say standard cout. I'm going to print out x, which is just going to be the value 0, and we're going to run that. And you can see it's implicitly convertible to 0. Now let's show it clashing. I'm going to say, instead of numbers, I'm going to say, I don't know how it ages. So something might be 0 years old, something might be 1 month old, whatever. 2, 3, dot dot dot. Now this is going to complain because these are both in global namespace, and they're going to clash. Okay. Redefinition. Previous was numerator, so is the new one, doesn't matter. Even has the same value, doesn't matter, it's redefinition. So there's a couple ways we can fix this. One way that modern C++ implemented was to make a new syntax where you say enum class. Okay. Enum class is actually scoped. So if I make these both enum classes, then they'll be scoped, and these won't clash anymore. However, it's going to introduce a new problem. I'm going to show that in a second. Here you go. Look at this. Now it can't be implicitly converted to an int. Now, you might think that you can change the type somehow to allow that to happen. And while you can set the type of the enum, it doesn't let you implicitly convert it to that type anyway, which is really strange. Like if I do uint8t, let's say, which I need to define, I'm going to say c standard int, which defines my, u or int number underscore t's. What this is saying is all of these are going to be unsigned 8-bit integers for the storage. So I can't store more than the value of 255, right? And 0 is going to be my lowest value I can possibly use. It doesn't mean that when I actually use this, it's going to let me use it like an unsigned 8-bit integer. So I'll even make this the same type, right? It's still not going to work. It's not going to be implicitly convertible, it's going to say. See that? So in this case, what it really wants you to do is say numbers. And here, I'd have to static cast it and say int. And it would let me use it. Because the type is numbers. So you have to pass it around like an actual enum type. So one thing I like to do to deal with the scoping issue, instead of doing it this way, is allow it to be convertible to an integer implicitly, but also scope it by sticking it into a namespace. So what I'll do here is I'll say namespace ns numbers. And I'll do the C way of doing it, and I'll say the underlying type is this. This will still work in C++ 11, and greater than that, I believe. And over here I'll do the same thing, namespace ns ages. That way, it's in the same scope, but the scope is this namespace, right? So these values are only defined in here, and these values are only defined in here. Alright, so now what I can do, since this is implicitly convertible, is just say this is an integer, and I can say this is ns numbers, and then the thing I want from ns numbers, the namespace, is the enum numbers, and then within that I want the actual value 0. So I no longer have to cast this to use it, I can just run it. Okay. And I can also do the same thing with another value. So I'll say int y equals ns ages, and then how about 3? Okay. I'm going to say standard cout y, standard inline. Oops. Okay. Did I not put that in ns ages? I did. Then ages, and then the value. Is that just the IntelliSense messing up? Cannot be used to initialize an entity of type int. Oh, because I lifted his class, right. There we go. That should work now, and it does. Anyway, that's the main thing I wanted to talk about with these enums. The next thing, though, is if you come from a language like C# or a couple other languages, you have the ability to reflect and maybe iterate through the enums. C++ has no such feature. I can't say something like for const auto val colon and then some enum like ns numbers, right? I can't just do a range iterator and loop through the possible values for the enum. I also can't easily say something like, okay, well, x equals this value. Can I just print, you know, the name of x, right? Like, right here I'm able to say that x equals 0, but what if I want to say it comes from ns enum 0? The only way really to do that is to do something like create a separate list that's like, I'm trying to think how I can explain this. I do a const char pointer, and I'll make it an array of those. I'll call it like g numbers or something. I could say it equals, and I could just do a bunch of strings like 0, or I could do 1, or I could do 2, and then 3, and then 4. And, you know, that'll work. That's fine. Then I could say something like my what was it? LPSC array numbers, I want to call it x. I'm going to say equals whatever that value is. So let's show that. So you could do something like that. The problem with this is if someone changes this and doesn't change this, or you change the order like this, then now it's out of sync and it's going to give you the wrong value. So I don't like that as a solution. I've actually made a macro that will let me iterate through enums with some shenanigans. And I think I'm going to perhaps write that here and show it off. It's going to take me a second to think about how to do this again, but essentially what you can do with the preprocessor macro is you can define something like a function, and if you put the parentheses right against the function, you can actually give it arguments like a, b, c. And what it'll do, if I say like func a, b, c, is if I type fn, and I do like 1, 2, 3, it's actually going to replace that with func 1, 2, 3. See that? It expands to this, func 1, 2, 3. So whatever I put in here, it could be meow, orc, I don't know, foo. It'll put those in there too, see? So we can do something like this. And the plan is to do something like, let's call it super enum. Okay? And what I'm going to do is I'm going to say ns for namespace name. I'm going to do, how about enum name? I'll do this, namespace name. I'll type it out. And I'm going to say, what? Members, right? It's going to be, yeah, I'll do that. So what's going to happen is I'm going to bring it to the next line. And I'm going to say enum. Actually, I want to type too. Enum name, comma, enum type. Okay. So enum, which has enum name, colon, enum type. Okay. And I'm going to stick it in a namespace. It's going to be namespace name. Okay, we'll end the namespace here. Okay, we'll end the enum here. Alright. Now let me think for a second. what I want to do here is I'm going to say const char star. I'm going to say enum members. And I'm going to say this equals, in fact, I want to make this mutable like that. It's going to equal va args. So whatever was passed with this triple dot, it's going to turn that into a string. So this is basically going to say all those arguments that I passed are going to be placed here, comma limited, but then I'm putting a pound sign in front of it, which means it gets converted into a string. So really, if I type something like super enum, and I do like namespace name, let's call it ns stuff, and then enum name is like stuff, and then type is going to be uint8t, and I do a, b, c for the members. What this really going to do is right here, this is going to be ABC, but it's going to become a string, so it'll be A, comma B, comma C. That's what it's going to give me, like that. Okay. I'm actually going to, I guess, keep that. I'll use it over here. Okay, let me think now. So if I have that string, the next thing I can do is I can say standard vector, how about? Do I even need that? Let me think. Yeah, I do. Okay. I'm going to say const char star. I'm going to say vec enum member names. Okay. Then I'm going to say parse enum member names. Okay, and this doesn't take any arguments. Doesn't return anything. What it's going to do is it's going to point to right here that string we defined, which includes all of the member names comma limited in a string. Okay, let's say const char e equals p. Actually, I'm not going to do that yet. I'm just going to say while, come on, while e equals structure p comma, I'm going to say comma. While I find a comma, I'm going to assign p to e plus 1. So I'm going to skip to the value after the comma. Okay. And every time I find a comma, I'm going to say equals 0. So I'm going to turn that comma into a 0. And then what I'm going to do is that vector I have, let's call it vec enum member names dot emplace back. I'm going to say p. So we're starting out at the beginning of the string. So imagine you have like 1, 2, 3 like this. What's going to happen is it's going to start at like this 1 right here. So here's p, there's a comma, it's e right there. We're going to 0 that out. Then we're going to go 1 after that. Okay, here's p2, right? And there's going to be a comma, we're going to 0 that out. And there's going to be p3. And that's the end of the list. Okay. Oops. I don't know what that does. I keep accidentally hitting that nano keystroke. Anyway. And then at the end of this, I still need to do the same thing again, because the last one won't have a comma after it. Okay, back enum member names. Okay, standard vector, const character pointer. I might want to do this in namespace name. Oh, you know what? That's what's going on. I forgot a backslash. There we go. Okay, so we have this right here is there. That should end the function. Yeah. Semicolon, semicolon, semicolon. Those are aligned properly. These are aligned properly. I don't think I'm missing anything. Okay. Anyway, we're gonna say Yeah, at that point I could really just get the actual enum value from here. So I'm going to define a super enum. I have it right here, ABC. Okay, so expands to this. Okay, we have ns stuff. We'll build with an enum called stuff, which is of type u8at. And inside of that we have a, b, and c, other spaces in there. So what I need to do here is I need to say, oops, way down here. There we go. That's what's right there. Okay, so if p is a space and p++. In fact, I can even do while it's a space. And I'll even be careful and say while it's a valid character and it's also a space. Alright, well, no, I don't need to do that because if it's a space, it's a valid character. Okay, so skip any spaces it finds. Okay. And keep zeroing out the commas. Yeah. Right, okay. That seems fine. Let's see what happens when I actually build it. Okay. So I'm missing an open curly brace somewhere. That finishes right here. That's the end of the namespace. Yep. Function starts here, ends there. While starts here and ends there. Yeah, okay. So what could it be complaining about right now? So namespace name, enum type, enum tag. Missing type specifier int assumed. Does not support default int. Okay. So, vector of constant pointer to character. Member names, void parse member names, okay. It's pointer to LPSC enum members. That's right. Okay. So start at that, and every time I'm able to find a comma from there, zero out the comma, and then add this member name start pointer to the vector. Okay, then skip past that comma that we zeroed, and then while we're on a space, continue skipping ahead. Okay, and once that's done, whatever p lands on, that's going to be the final member. And then we're done with that function. Oh, you know what? I forgot something too. That. I actually need to define the enum itself, right? That was a bit silly. Yeah. So inside the enum, I'm going to need to do va args again. So now I have an enum defined with these types. Okay. Now I'm going to do one more thing after that. I'm actually going to say sentinel. I'll even put some stuff around it. And the reason for this is it's going to give me the number of items in here. I mean, I guess I don't really need to do that because I can look at the size of the vector, but if I don't want to use a vector for this, I could just use a flat array, and that would work fine too. The only problem with this is I can't actually, what do I say? I can't really assign the values if I do this. Let's give this a try real quick. Right, it doesn't know what vector is, so let's actually include vector. Okay. Really? Cannot assign variable as cause. Okay, that's true. Yeah. Okay. Missing open curly brace. About a formal list. Missing function header old style formal list. Okay, void parse member names void. That's right. My enum right here has ABC and Sentinel in it. Okay, that's right. The string looks right. The vector, oh, has no semicolon. Where am I defining that vector? Vector, vector, vector. Where are you? It's right here. It does have a semicolon. It's lying to me. Why is it lying to me? Oh, right here. There it is. It just wrapped the next line, so it confused me. Alright. Parse member name starts here. While. Okay, that ends. The function parse member names ends here. This is the end of the... Oh, the enum. Oops. That shouldn't be there. That was a mistake. Yeah, so the namespace starts here and ends there. The enums are right here. The function's right here and ends there. There's the while loop. Let's try that again. Okay, so what are we missing now? Okay, so it starts here. We have another. Okay, namespace and then the enum, that's why. And the enum ends here. Then we're defining the string and the vector. Then we define the function, which starts here. There's the while loop starting. While loop ends. Okay, function ends. Namespace ends. I can't see anything that looks obviously wrong about this. Expand inline. Let's see what we get. Oh, you know what? Did I actually type? Yeah, I never typed namespace. Namespace. Now what? There we go. Now it actually made it. So it's called ns_stuff, and then the enum is called stuff. So let's do this. ns_stuff, colon. Now what do we have in here? Parse member names. Yeah. Just gotta call that ns_stuff. Where's my vec? There it is. So for const auto. I'm gonna say. I'm not gonna do that. I'm gonna say for each character pointer, it's constant character pointer, BSC member name in this range. Okay, standard cout, and we're gonna do member name. Okay. And it's gonna be LBSC member name. Okay. And look at that. Now we can see the member names. Isn't that cool? We can iterate through it. And that also means that if we reorder these, it'll stay correct. So, where am I defining that super enum? Right here. So, if I reorder these now, whenever I talk about their name, the right name will be associated with the right value. So, I didn't actually show the value. Let's do that too. I'm gonna say like, points to like has that value. I'm gonna say in fact, I don't want to do that. Yeah, I'm gonna say ns_stuff, and then stuff is the type of the enum I'm using. I want to say stuff equals 0, or even equals ns_stuff stuff a. Start at the beginning one. I'm gonna add a new scope here, and each time I'm gonna say stuff plus plus, and I'm gonna actually print out the value of stuff. This is not going to let me. Does not define this operator or a conversion that is acceptable. I guess I can't actually do that. fine. I'll say size t, index, fact, enum, member, index. I'll be really explicit. That plus plus. And over here, I'm going to dump the member index. So there we go. A0 sees 1, B's 2. So that works. I'm just going to stick this over here, in case anyone wants to play with that. But essentially, this lets you create an enum that's scoped, it's implicitly convertible to an int, it has the max value you want by specifying the enum type, and it has any number of arguments. I'm going to make this slightly better. Instead of a vector, what I'm going to do here is I'm going to make this actually a constant character pointer array. I'm going to call it LPSC array enum member names. And the number of items I have here are going to be equal to sentinel. So I'm adding this extra special note at the end of the list that you didn't define, just so I know how many values there are. So imagine you have enum numbers, let's say, and we have, I don't know, something like 0, 1, 2, and that's it, right? I'm automatically adding this sentinel at the end, and this is 0, 1, 2, 3, and there are 1, 2, 3 items. So it's always going to be equal to the number of items I have in the enum. Okay, so that's going to tell me exactly how big to make this array. And by default, let's just set it to 0 for all the members. And instead of in-placing back on this, what I want to do is I'm going to do size t, st, oh geez, let me think for a second. Let's just call it index equals 0. Okay, so each time I'm going to say LPSC array vec enum member names position that index plus plus, so whatever it currently is, we're going to use that, and then we're going to add to it afterwards, equals p. Okay, and I'm going to do one more thing here. I'm going to say const size t st member count equals, and it's going to be sentinel. Yeah. CNTI-NEL. CNTI-NEL. Why is it complaining about that? Oh, right here. That's why. Okay, and down here I'm going to need to be a little bit crafty. Instead of this, I'm going to have to say something like, for size t I, let's say equals 0. In fact, I'm just going to use this whole name here. It's less than ns stuff, and then it's going to be st member count, this whole thing plus plus. Oops, plus plus. Okay. The member name I'm going to get is going to come from ns stuff, and then LPSC array vec member names position that. Okay. Yeah. And I did mess something up, it looks like, but we'll see. Okay, the vector is undeclared. Right, okay. So in this case, it's going to be this whole thing equals p. And I don't need to mess with that anymore. Okay, so we have A, B. Looks like we're missing our C down here. Wait, we have A and C, no B, is that right? There should be a C in there. It should be A, C, B. How is it skipping the C? 0, 1, 2. So we do have a pointer to a constant character. We have an array of those. Each one is 0. Okay. We're starting at 0. Each time we fill it with the current value. Yeah, that looks right. Oh, I see what happened. I was incrementing it right here inside the loop. Oops. Alright, 0, 1, 2. So that still works. That's nice. And now I don't even have to have vector defined if I don't want to. So this solution right here really should work with, well, namespaces don't exist in C, but yeah, it would almost work in C. Alright. And I could get rid of this stircher right here, so I wouldn't have to define string.h if I want to make my own little function for it. But I'm fine with that for now. If anyone else wants to play with that, string, let's see, string, then yeah, you know, feel free to improve it and, you know, give back any of your changes, post it somewhere, maybe leave it in the comments. But that's a way that you can, I think, improve the, what do I say, safety of using enums in C++ by a little bit. Because this, like I said, prevents the problem of having an out-of-sync array of labels for things, like these right here, with the actual values down here. This gives you both for free. And I can do it for as many enums as I want. Of course, one drawback for this might be that you only want the enum itself defined and accessible in one translation unit, like so one source file. And how do I word this? You want the enum defined everywhere, but you want the rest of the stuff defined in only one place, right? So what you might have to do is like supernum impl, right, implementation. Maybe you define super enum def, right, or declaration, and we'll do the same arguments, right? And in this case, it's just going to be, you know, that part. And that way I can include it in multiple files. So, yeah, everywhere you can define it here, except for maybe one spot. And I guess I could maybe show it off by having multiple source files. Let's do this. I don't know, extra.cpp. Not a very creative name, but we'll do that. So I want to use the super enum declaration. I'm going to have a common header file. Let's call this super enum.h. Okay. And I'm just going to take both of these enums here. Okay. And I'm going to do if not defined super enum header defines super enum header and if. Okay, and then here I want to include super enum header, not header.h. I'm going to copy that. Okay, let's include it over here. And then I should be able to use super enum, let's say, implementation. So one source file is going to have the implementation, and the other source files are going to have the declarations. So I'm going to define the same type here. Declaration. Kind of surprised it's, oh, jeez. Yeah. Okay. Let's see what happens. Okay, it doesn't name a type. Right, so over here, I'm also going to want C standard int. Not stinged. C standard int, okay. And look at that. It lets me do it. Now, if I did the implementation in two places, this wouldn't work because it's going to have multiple definitions. Well, also because it wants C string. But look, this implementation actually defines a function called parse enum member names, right? So it can't be in two places. And maybe I have some kind of like, I don't know, file, I call it enums, right? Project enums. So in here what I'll do is I'm actually going to specify this right here. I'm going to say enums I'm going to say if stuff impl. In fact, if defined that, then we're going to undefine that and say end if. Okay, we're going to do pragma once, if not defined, enums header, we're going to define enums header, and if. And then what we can do is over here we say else, if we didn't ask for the implementation, then instead we're just going to do the declaration. Where is that? And I can even do this instead as well. I'm trying to think here. Enum, let's say define, enum def type. I'm going to say this, enum macro type. Okay. So in this case, I'm going to say the enum macro type is just going to be this. Yeah. Otherwise, it's going to be that. Okay. That makes a lot more sense. Yeah. Oops. Like that. Okay. So in this case, I'm actually just going to use whatever macro type I need. So if we're being told to implement stuff, so do stuff, implementation, then we're going to do that. Okay. And over here I'm going to need include, I'm going to say super enum.h, so now it knows how. And these over here, I'm not going to include that on. I'm going to include instead enums.h. And same thing over here. I'm just going to call it enums.h. So now the whole project depends on that one file for all its enums. Okay, it's never resolved because I never defined it. So I define it one place. I'm going to say do enums impl or stuff. Was it stuff impl? What did I call that? Do stuff impl. That's right. That should work. Okay. Okay, so it doesn't know the type here. Include. Oops. Include. We do C standard int. Okay. Don't need that here anymore, do I? Right. So I'm going to say int foo void. In fact, void foo void. See if it compiles. I'm going to say ns stuff index equals that, and then it's going to be a enums, right? Yeah. Oh, I called it the CPP. I didn't mean to do that. I meant for it to be a .h file. Oops. There we go. That's better. Anyway, you can see the whole project and still use it. And if I want, I can even do forward declaration of that function. Void, what was it? Foo, void. I think that's what I called it. Yeah, foo. Okay, and then in main, I'm just going to call foo. Okay. And let's do standard. Oops. Cout. Greetings from extra.cp's foo function. Okay. Right, I didn't include iostream here. Include iostream. Let's do that. And look at that. Greetings from the foo function. Cool. So now we have a way to define an enum that is able to be enumerated. It's able to have the names of each member of the enum dumped. It's implicitly convertible to an integer. It's in its own scope by a namespace. It has a type that bounds the size of all the arguments, or members I should say, of the enum safely. And I have a way to abstract away from this such that one is a definition and one is an implementation based on some kind of guard here. So I can define the implementation in one spot while including this everywhere. So the CP file that I want to have the implementation in, I just define this, do stuff implementation before I include the header. This is the same kind of thing you'll see happen in some single header libraries. One of them I can think of is called SDB image, and there's another one like SDB rectpack. Those are some pretty great libraries that I like a lot. Anyway, I'm sure I've had some people's eyes glaze over and lost a few people, but I think that this is a useful thing. I've actually used it in one of my projects, this exact enum type. And specifically, I used it for OpenGL for grabbing uniform locations inside of a shader in a way that I can select it at constant time. A lot of people find uniform locations with like gl get uniform, something like that. And when they do that, they'll store it in like a standard map. Standard map of gl int, or maybe some kind of like string to gl int or whatever it's going to be. Maybe it's like a uniform location to something else. I think typically, yeah, it's like a string to an int. Anyway, hopefully some of you guys found it useful. If you guys have any comments, any ideas for improvements, any criticisms, feel free to leave those in the comments. And just, in general, like, comment, and subscribe, and I'll catch you guys later. Have a good one.